Oxidation and reduction in terms of electron transfer is actually for in chemistry is to prove there is redox reaction when there's electron transfer. Now there's four definition of redox. The one of it is lose and gain of electron. So within a chemical equation, losing and gaining electron cannot be seen directly. So it has to be always written in half equation. So for example, you have equation, right? Half, this is called half equation because it involves electrons. So this is not a full equation because it's only involving either receiving or donating electron. That's why it's called half equation. So once you add half and half equation, then you will get what we call as ionic equation or the full equation. So that's what I'm going to explain today, which is half equation and also ionic equation. So in any what you call redox reaction, there must be transfer of electron. That means receiving and also donation of electron. Now without receive and donate electron, there won't be any redox reaction. So that part you need to clearly understand. So that's why we have this activity, okay, conducted in the laboratory in the first chapter, which is to see using galvanometer, all right, how electron is transferred at a distance. At a distance means from one area to another area, all right, not in the same place lah, from a distance. So let's look at this equation first. Initially, what we see is a reaction between magnesium metal and oxygen, and you get magnesium oxide. So if you want to explain in terms of receive and donate oxygen, all right, gain and losing oxygen, you are not able to do that because if you look at this equation, magnesium is the one going to gain the electron, but where is the loss of gain oxygen, but where is the loss of oxygen? So it's not clearly seen. So that's why for this kind of equation, if we know it's a redox reaction, so we write down what we call as half equation. Right, so half equation for magnesium will be magnesium changing to magnesium ion. So how do you know magnesium is going to change to magnesium ion? Because it's a metal and normally metal donates electron. So in any reaction, metal has the tendency to donate electron, whereas non-metal has the tendency to receive electron. So that's why from here I know, all right, this is involving burning of magnesium metal. So of course there will be transfer of electron, right? So how do I how am I sure? Because I see there's metal and I see non-metal. So metal and non-metal, when they react, it has to be an ionic equation. So ionic equation involves transfer of electron. So this call your half equation. Magnesium, all right, becomes magnesium ion by donating 2 electron. Oxygen gas receives 4 electron to become oxide. So how do I get these two in front of the oxide? This is to balance the amount of electron received. So you have 2 oxygen atom, all right, so 1 oxygen atom will receive 2 electron. So if you have 2 oxygen atom producing 1 oxygen molecule, so you have to have 4 electrons, right? So this part I don't have to explain, it's the same thing. So why magnesium undergoes oxidation? It loses electron. So oxygen, whereas oxygen gas all right, gains electron, so it undergoes reduction. So oxidizing agent here is the substance that undergoes reduction. So undergoes reduction here is oxygen. So oxygen gas is the right oxidizing agent. Okay, magnesium undergoes oxidation. So magnesium is a reducing substance. To further prove electron transfer, this is an experiment conducted in the lab. All right, so this is called transfer of electron at a distance because we use a U-tube. So the U-tube consists of two different solutions. So this solution, one solution will be solution that actually undergoes oxidation, and the other one undergoes reduction. So how do we know which one undergoes oxidation, which one undergoes reduction? So later on we will actually further discuss on different kind of solution having different ability, whether that particular solution undergoes oxidation or reduction. Like here, for example, this table states different solution which you need to know that undergoes oxidation and reduction. Okay, so to explain this activity, you have iron 2 sulfate and potassium manganate 7. Now, potassium manganate 7, as you all know, is an oxidizing agent. So if it's an oxidizing agent, it will undergo reduction, meaning that manganate here, all right, manganate MnO4 minus will receive the electron donated by not iron 2 sulfate, iron 2 only, all right, because the ion is the one going to release the electron. So the electron will transfer from, okay, iron 2 sulfate to potassium manganate. Now, when there is a reaction, normally our observation, we can observe there's color change. So that if there is a reaction, there must be some kind of color change here. So here iron 2 is green, so it will change to brown. So brown is actually iron 3. So from iron 2 it forms iron 3. So this is here, what is taking part here is oxidation. So the electron given up by iron 2 is transferred to manganate. Okay, of course the whole solution, the substance is called potassium manganate, but involved in the equation, half equation, or involved in gaining and losing electron is just the ions. So you need to be specific, all right, in which ion is going to receive and donate electron. So how do we know? We have to know what is the function of the substance. So normally iron 2 normally will become iron 3. If we have iron 3, it normally becomes iron 2. And if you have potassium manganate, that means potassium manganate or potassium dichromate will always be the oxidizing agent. So the negative terminal is determined by deflection of the galvanometer. So if the galvanometer deflects towards potassium manganate, that means the electron is transferred from iron 2 sulfate to to potassium manganate. So the negative terminal here, all right, will be your iron 2 sulfate solution, and this will be your positive terminal. That means you must look for where the electron is transferred. So that will be your negative terminal. So in conclusion, the deflection of the galvanometer shows that there is transfer of electron. So if there's deflection, that means there's transfer of electron through the connecting wires, not the solution, but the connecting wires from the reducing agent. Why? Because negative terminal is where the electron is given out. So donating electron is oxidation. So the solution that is donating the electron is called your reducing agent. All right. Then next we go to the writing of half equation. So how do you write a half equation? This is what is happening. Iron 2 is changing to iron 3. So how does it change? By actually donating one electron. Whereas the manganate, all right, manganate actually, what happens in manganate is it will receive actually 5 electrons. So manganate here, how do you know 5 is later on we need to calculate. We will learn how to calculate the oxidation number. So here normally we call potassium manganate. Okay, acidified potassium manganate because it is in a acidic solution. Right? So what is going to happen is manganate MnO4 minus is going to receive, all right, hydrogen ion, the presence of hydrogen ion here to form mangan 2, all right, to form mangan 2. Then how do we further write the equation to balance is this mangan, okay, mangan 7 actually, in order to balance both the equation, all right, MnO4 will receive 8 electron. Okay, how did I get 8? Okay, here we have to balance, right, the amount of what you call it, okay, we have to balance the product and substance. So if you see here there's O, but at the end the product there's no O, this is not balanced. That means there's some other product missing here. So what is missing is your water. That's why suddenly you have from acidified potassium manganate you have water. So this is to balance the equation. So if you put water, H2O here, okay, what's going to happen is now the hydrogen won't be balanced anymore. All right, so you have 4 oxygen here, so you must have 4 here. So hydrogen becomes 8, right? And then now is how we balance the electron. So mangan 7 is going to receive electron. So how is the shift happening from MnO, Mn here to Mn2 plus? So why is it called mangan 7? Is because the oxidation number of Mn here is 7 plus. So 7 plus to become 2 plus, it has to receive 5 electrons. So that's why it will receive 5 electrons. Right? So that's the half equation for mangan. Okay, now you want to add half and half, you must balance the number of electrons. So 5 electron, 1 electron not balanced. So you have to balance, receive and donate. So it times everything 5. Okay, why? Because it's like linear equation. If linear equation, you have times the whole thing with 5. Then only you add. So when you add, the electron be cancelled off. So whatever is written on your left is written on your left. So this is called your ionic equation or your full equation. So that is all that I want to explain about electron transfer.